All right, so the reason why I had you do this is notice when we connect this to the unit circle, this is always going to be, this horizontal line is always going to be the x-axis, all right? So when we're talking about the 30-degree angle, it could be in the first quadrant, second quadrant, third quadrant, fourth quadrant. And in each of those cases, when we're talking about the 30-degree angle, right, you have a vertical and a horizontal side. But when we're talking about the 30-degree angle, in each case, how big is the vertical side? 1. So you see how the vertical side is always the same? And then the horizontal side is obviously always going to be the same, right? So now, if I want to find sine of 30, okay, I can either say opposite over hypotenuse, or I could just say the vertical side, right? The sine, for the sine of 30, which one am I going to use? The vertical or the horizontal? In this case, I'm going to use the vertical, right? So it's going to be 1/2. In the next triangle, for the sine of 30, which one am I going to use? Vertical or horizontal? Vertical again. So here I use vertical, here I use vertical. In the bottom triangle, for sine of 30, I'm going to use the vertical, okay? And it's going to be 1/2. For sine of 30 in the last one, I'm going to use the vertical side, and it's going to be 1/2. Basically, what the pattern is that I want you to see is each time sine of 30 is associated with which leg, vertical or horizontal? Vertical. And that's always going to be that way. Sine is always going to be the vertical over the horizontal, because from now on our triangles are always going to be oriented this way. So now if I want to do the cosine of 30, that's going to be the horizontal, right? I'm going to use the horizontal, root 3 over 2. Here, to find cosine, I'm going to use the horizontal, root 3 over 2. And same thing here, horizontal, horizontal. So the big idea I want you to get out of this is that in every case from now on, sine is always going to be the vertical, cosine the horizontal. Okay? Now,
What is 30?
right. So now let's do, what if, okay, so now let's do the triangles. Let's flip the triangles now. Now I'm going to make these not 30, but 60. Okay, so let's go ahead and label all the sides now. 1, root 3, and 2. So now, the 1 is going to be here on the bottom. Root 3 and 2. 1, root 3 and 2. 1, root 3 and 2. 1, root 3 and 2. All right, now I want to find the sine of 60. So again, we have a horizontal and we have a vertical, right? So, okay, so the sine of 60, right? It's going to be what? For the sine of, it's going to be root 3 over 2. So which one did I use? Horizontal or vertical? Vertical again. In the next case, sine of 60 is the opposite one, root 3 over 2. Again, I use the vertical. So again, and no matter what, for the sine, I'm using the vertical side. For the cosine, I'm going to be using the horizontal side, 1/2. So that's what I want you to remember. And you'll see me like motioning all the time. When I say sine, I immediately, like with my hand, I do this vertical motion. When I say cosine, I do a horizontal motion. Because in my mind, sine is just the vertical side, cosine is just the horizontal side. All right, now, similarly, I know we got the point of that one. In a 45, 45, 90 triangle, we have two congruent acute angles, and they both measure 45 degrees. Now, these 45 degrees are opposite to congruent legs. And if we say that their measures are 1, then how big is the hypotenuse? Root 2. So if I label that like this, it's 1, 1, root 2. Now here, I'm only going to do one of the triangles. So I'm going to label that 45, and I'm going to do 1, 1, root 2. All right, for the sine, do I use the horizontal or vertical leg? Well, right. So technically it's the vertical leg, but it really does not matter. It's 1 over root 2. For the cosine, it's the horizontal leg, and again, it's 1 over root 2. Okay? All right, so let's just take an inventory of all of the possible values we got. Okay? Here, all these sines and cosines of 30, the two values that we got were 1/2 and root 3 over 2. Okay? Here, what were some of the answers that we got? 1/2 and root 3 over 2. Here, what were some of the answers we got? 1 over root 2. Moral of the story. When we do sine or cosine of our 30, 60, 45 degree angles, what are the three possibilities that we're going to get? Right, 1/2, root 3 over 2, 1 over root 2. So these are going to be basically the answers to sine and cosine of these angles. Okay, now, this is all fine, okay, when you have sides of 1, 1, root 2, or when you have sides of 1, root 3, and 2. That's all fine when we're taking geometry. But then when we move on, and when we have to talk about the unit circle, right? What's the big deal about a unit circle? What is a unit circle? A unit circle is a circle that has a radius of 1. So now, if I wanted to put a triangle in here, all right, which one of those sides, the red, the blue, or the green, is a radius? The red is a radius. It can only be a 1 because this is a circle with a radius of 1. Now look at this triangle up here. It's got a hypotenuse of root 2. Can that fit in here? Well, no, because the hypotenuse, which is the red one, can only be 1. That can't fit in here. So you know what I have to do is I have to rescale my triangles. So let's take a look at the 30, 60, 90 here. Okay. Look at the vertical leg. How big would the vertical leg be? 1, root 3, or 2? There's tissue here somewhere. So how big would that vertical leg be? 1, root 3, or 2? 1. And this is a root 3. And that's a 2. Except I can't have a hypotenuse of 2. It needs to be a 1. What can I divide it by to make it a 1? 2. So let's divide that by 2. So we're rescaling. On Photoshop, if you decrease like the width of an image, you have to decrease the length by the same amount, right? So now I have to decrease, so I have to divide everything by 2. So now what are my new triangle? What are my new lengths? 1, 1/2, and root 3 over 2. Let's do the same for the other one. It used to be 1, 1, and root 2. Now I'm going to divide everything by root 2. So I'm going to get 1 and 1 over root 2's everywhere. So from now on, these are going to be what we're going to use, not those other ones. Okay? These are now, these ones with the hypotenuse of root 2 and 2, those are dead to us now. Okay? The only ones we're going to use are these. Okay, so let me ask you this now. What if you wanted to find the sine of 30? So let me just write down SOHCAHTOA here. If you wanted to find the sine of 30, it would be opposite over hypotenuse. 1/2 over 1. Cosine would be adjacent over 1, hypotenuse. Right? So in this case, when the hypotenuse is 1, and when you're doing opposite over hypotenuse, adjacent over hypotenuse, and when you're dividing by 1, what happens? Well, when you have like, it stays the same. When you have 5 divided by 1, 7 divided by 1, 1/2 divided by 1, it stays the same. So when you rescale the triangle, one of the benefits is, when you're doing SOHCAHTOA, you can just drop the H. So now if I wanted to find the sine, it's just opposite 1/2. If I want to find the cosine, it's just adjacent √3/2. Okay? All right. Now, I put this other radian measure part in last year because I know a lot of students have difficulty converting mentally, like between like what pi/3, pi/6, and pi/4 are. Okay? So now, 180 degrees is pi, right? Okay? Now, suppose I took 180 and I want to get 30 out of it. What should I do to 180 to get 30? Huh? Okay, so if I have 180, what can I divide it by in order to get 30? 6, right? I divide by 6. So 180 divided by 6 is 30. But since 180 is the same as pi, that's the same as, right, pi/6. All right? So now suppose I want to get 60. I take 180 and divide it by how much? 3. Well, that's the same as pi/3. If I have 180 and I want to get 45, what do I divide by? 4. Well, that's the same as pi/4. Okay? So now when you see pi/3, think, okay, pi/3, that's 180/3, yeah, that's 60. Okay? All right, now evaluate the following trig function. So now I want sine of pi/6. Okay? Sine of pi/6. So pi/6 is like the which angle? 30 or 60? Pi/6 is like the 30. So if I go here and I want the sine of 30, it's just the opposite 1/2. Okay? So that's how quick I want that to be. All right, so suppose I want cosine of pi/4. Pi/4 is which angle? It's 45 degrees, so it'll be 1 over √2. Okay, now I have cosecant of pi/3. Pi/3 is like 60 degrees, right? And cosecant is like sine. So I go up here. Sine of 60 is this one. But now I'm going to take the cosecant, right? 1 over √3/2, which is just 2 over √3. So if I have 1 over √3/2, it's just 2 over √3. I just flip the fraction. So cotangent of pi/6 then. Pi/6 is which angle? 30. Cotangent is adjacent over opposite, right? √3/2 divided by 1/2. Whoa. No. Unfortunately not. Right. So it's √3/2 divided by 1/2. Right, now if you have the same denominator, you just cancel them out. So now, what's left on the top there? Just a √3, and on the bottom is a 1, so it's just √3. Okay? All right, so we said the unit circle is a circle with a radius of 1. Okay. So now, so if I want to talk about like the 30 degree, that's right here. Okay. All right. The 30 degree has 2 lengths, right? A horizontal and a vertical. Right? Now, so 30 and 60 are in the same triangle, right? Okay. So 30 and 60, let's just do another inventory here. 30 and 60 are in the same triangle and 45 is in the other. In the 30-60 triangle, what are the possible sides? Either a half or a √3/2. Now, here is the trick. Why did I write that so small? So it's either a half or root 3 over 2. Now here's the trick. If you're talking about a small angle, it faces a small side. So here we have an angle of 30. Is that the smaller or the larger angle we said? Smaller. So it faces the smaller side. Between 1/2 and root 3 over 2, which is it? 1/2. So this is root 3 over 2. All right? So to get to that point, how much do I go in the x-axis? Root 3 over 2. And how much do I go in the y-axis? 1/2. So to get to that point, I go over root 3 over 2 up 1/2. Okay? Now, what if we're talking about the 60 degree? Let's talk about the 60 degree. I have 2 side lengths. Okay, now, if this is the 60 degree, is that the smaller or the larger angle? Larger. So now, this vertical side, is it the smaller or the larger? This vertical side. Larger. So if it's larger, larger. So how big is that vertical side? Root 3 over 2. And this little side is 1/2. Now, for cosine, do I use the vertical or the horizontal? Horizontal. So how much would the cosine of 60 be? 1/2. Okay? All right. So let's do some of these here. Okay? All right. So I want to find the cosine of pi over 4. Right? Pi over 4. So pi over 4 looks like what? That's a 45. How big are the sides for the 45 degree? 1 over root 2, 1 over root 2. So if I want to talk about the cosine of pi over 4, horizontal, vertical, it's the same. Technically, it's the horizontal, and it'll be 1 over root 2. All right, let's talk about sine of 120. First, we're going to draw 120 degrees. What quadrant does that land in? 2. Now, if I'm looking for the sine, is that positive or negative in quadrant 2? Positive, because it's all students take calculus. Okay, now, what's the reference angle there? Reference angle? 60. So here's what I say now. For a 30, 60, 90, okay, so that's 60 degrees, right? Is that, okay, sine is this vertical side, right? For a 60 degree, is that vertical side 1/2 or root 3 over 2? Root 3 over 2 because it's the larger side. So the answer here is just positive root 3 over 2. Okay? Now let's do this one. Cotangent of 210. Let's draw it. What quadrant will that land in? 3. In that quadrant, is cotangent positive or negative? All students take, so it's positive. What's the reference angle? 30 degrees. So now, for the 30 degree, my sides are 1/2 root 3 over 2. If I want cotangent, it's what over what? Cotangent is adjacent over opposite. So it's root 3 over 2 divided by 1/2. Now, same denominator cancels, and I have root 3 over 1, which is root 3. Okay? Now, let's do this next one. Secant of 5 pi over 3. Remember why, remember I was making you draw all these angles? Well, this is why. So this is what? This is 1 and 2/3 pi. So what quadrant does that land me in?
Oh, no. Sorry.
1 and another 2/3 pi. That's almost a full pi. 4. Okay, secant, is that positive or negative in quadrant 4?
It's positive.
Positive, because it's like cosine. Secant is like cosine. So if all students take calculus, cosine is positive there. Huh?
So it would be pi over 3, which is 60.
Yeah, so it's positive there. The reference angle is pi over 3, which is like the 60 degree. And we know that for a 60-degree angle, the vertical side, is the vertical side? How much is it? Root 3 over 2. So how do I know that? This is an angle of pi over 3, which is like the 60. That's the larger of the two. That means that's the larger of the two. Now, for the cosine, do I want horizontal or vertical? This is my angle theta.
You want horizontal.
For E, it's in the 4th quadrant, and over there, tangent is negative. Now, the reference angle is what? In this case, 30 degrees, which is, yeah, pi over 6, which is 30 degrees. Now, tangent is opposite over adjacent, right? For 30 degrees, how much is the opposite? 30 degrees is the smaller one. The one opposite the smaller is 1/2, the smaller angle. So this is root 3 over 2. And we said that this is a negative. So when I get rid of these 2's, I have negative 1 over root 3. Okay? If you want to take a look at this, 30 degrees will face 1/2, and this is root 3 over 2. Now, in the other case, we are in the 4th quadrant where cosine is positive. Okay? The reference angle is pi over 3, which is the larger angle, so it faces the larger side. So how much is the cosine? Cosine is 1 over 2. All right? So on that note, it's this homework that'll be due tomorrow, Wednesday, right?